Like, subscribe and press the bell icon for more videos from PHN Learn. For more videos, download our app from the Play Store. Hello guys, so in this session we are going to learn more about algorithms. Now this data structure is completely based on your algorithms only, and there are two types of your algorithm, that are your sorting and searching. And based on these two algorithms only, many different kinds of algorithms are developed and derived basically. But these two search and sort algorithms are there, right? Now this algorithm plays a very important role in our programming language. And these algorithms have many different approaches also. In the previous lectures, just now I told you that there are complexity. Means here we have time complexity, space complexity and many more. Right? And similarly, there are two types of approaches of your algorithms, and that are your theoretical as well as practical. Theoretical means what? The moment you are getting a problem statement, you need to write it down. You need to specify the steps over there, and that is nothing but your theoretical. Whatever you are doing with your pen and paper, that is nothing but your theoretical. Whereas if you take the practical approach, then the implementation of that algorithm. In the fruit salad example, we saw that what we did, we made the fruit salad, but using step by step. That was a practical approach for that. We saw that example that the character was what? It was washing the fruits, then it cut the fruit, then as per the recipe made the fruit salad. So the basic outcome I got. But that was what? A practical approach. So similarly, if you are performing the algorithms, first of all you are creating that algorithm, that is nothing but your theoretical. Whereas you have to implement that, you have to perform it in your practical way, that is nothing but your practical approach of your algorithm. Now this algorithm is based on many different factors. So these algorithms are also, some are theoretical algorithms, whereas some are practical algorithms. Okay, so this was the approaches of your algorithms. Now these approaches are bifurcated into many different types. Based on these types, the approaches are categorized. Okay, like these approaches are, the algorithm approaches are based on Buret force application, then divide and conquer rule, greedy algorithm, and so on. This is the list, this is the categories over which our algorithm approaches are based. These are the steps how we can approach a particular problem. Greedy algorithm, then divide and conquer. These are what? These are the steps. These are a specified algorithm, and these are the approach. It gives us the approach how you can how you can start a particular problem statement. If you have given the problem statement, then how you can think for that, how you can start the implementation for that. These are the steps you will know. And all these steps in the further lectures we are going to learn. We are going to learn everything about divide and conquer rule, greedy algorithms and everything. Okay, but basically these are the steps over which you need to understand how to approach the problem statement. Right? And that's the reason we every time say that algorithm is a very important problem. Why? Because it shows the basic concept. Every time remember, if at all you are starting with a new programming language, then you need to have a strong basic for that. If at all you don't have your basic strong, then you won't be understanding the advanced part. As simple as that. Right? So therefore you need to have a basic strong. That's the reason you need to have your algorithm part strong, because based on that algorithm only you are going to solve every problem. Just now we saw that theoretical and implementation part, right? Practical part. So practical means what? Implementing a certain step. Like if I take an example of palindrome, Armstrong, these are the formats which are already known, right? Means whatever programming language you take, the steps of finding the output, of finding the palindrome, or finding an Armstrong number is one and the same. It doesn't change, right? So therefore, these are what the final approach. But let's take that now a new concept has come and now you don't know how to solve it. At that time, your algorithms only help you. These only states that how to approach that particular statement. If at all your that implementation, your problems get similar to your greedy algorithm, which we will learn in the next session. If at all it is similar with the greedy algorithm, then you can perform the implementation using that approach, using greedy algorithm approach, right? But now the prerequisite what? You should know the greedy. What do you understand by greedy algorithm? Each and every implementation is based on these type of approaches only. You just need to bifurcate your problem system and then you are good to go. Right? So this is how the bifurcation is done. This is how the bifurcation of approaches of algorithms are done. Now again, the most important factor in algorithm which comes is your complexity. And this complexity is bifurcated into two types, that is your time complexity and the space complexity. Now what happens is, if I take a sorting example, okay, now in sorting example what happens, you have multiple types of sorting like bubble sort, then insertion sort, selection sort, radix sort. These are the multiple techniques of sorting only. But in sorting, what is happening? Either it is sorting the array in ascending order or in descending order. The same process is happening, but still for that same process only, multiple types of sorting is generated. Why is it so? Now here comes your complexity part. Each and every type of sorting algorithm has its own time and space complexity. Complexity means what? Optimization, right? Means how much faster the program is getting executed. Sometimes happens when you run your program, it takes some time. Like sometimes happens it takes so long that we get a thinking like our system is hanged. But that's not the case. Because of the complexity, because of the trouble in that program, you haven't write a program in an easier way. That's the reason your program is not executing properly in a fraction of seconds. It is taking certain time, right? And here comes that's the reason we need to know, we need to have a complexity concept. If you don't have that complexity concept, this means what? This basically complexity does what? It gives which algorithm, which approach is to be applied so that it will get executed faster. Right? This complexity only gives us the idea. And this every type of your sorting algorithm has its own space and time complexity. Maybe bubble sort is having more complexity than the radix sort, and so on. These are the bifurcations. That's the reason there were many different types of algorithm, sorting algorithm, because each and every have different optimization complexity over there, right? And every time this therefore it is not the case that you are providing an algorithm and you are running the code, that's it. No. If at all you want to become an efficient coder, it is necessary for you to have a proper code, basically with the comments and a proper understandable code and an efficient code. Secondly, to have an efficient code means what? It should get executed properly and effectively and efficiently. Means at the fraction of second only. It should not take time. Means what? The complexity of that particular algorithm which you have applied over there, that should be less. And if at all the condition is getting satisfied, then means what? You are efficient coder. Right? That's the reason why you need to know so much in deep depth about your algorithms. If you don't have your basic algorithm, what is algorithm and what are the approaches and everything clear, then it will be very difficult for you to do the code. Okay, so every program has its own approach, every program has its own complexity. Now again there is a concept that how to find out the complexity. Again here we have a concept of big data, big O, big theta, big beta. These are the concept. Big omega, right? So these are the concept which we will see in the next lecture. Okay, so in the next lecture we are going to see how to find the time and space complexity of a particular program and what are these notations also. Okay, so this was the complete about your algorithms, a complete theoretical part of your algorithms. Now from the next lecture we are going to learn how to implement all these things. Okay, so this was all about today's session. Hope you have understood it. So for now, thank you and goodbye. For more videos, download our app from the Play Store.